6. Anyone need me to do any bit of number 6?
You do the last part.
6 part 2? So 6 part 2 is, sorry, log of 72 to the base 8 minus log of 9/8 to the base 8. Right, okay, so what we can do is if it was minus, that means it was originally divided. So that was originally log to the base 8 of 72 divided by 9/8. Okay, so you can just do that in the calculator. So multiply by 8 once. Log is 64. 64, I think, when you do that in the calculator. And 8 squared will give you 64, so the answer is 2. So 8 to the power of 2 will give me 64. So the answer is 2. Is that alright? Right, we good? That was number 6. I think it was 8. Any bit of number 8?
3.
Sorry. In number 8 it says common logs, and I never told you what a common log was. Sure I didn't? Right, in number 8 it says common log. Right, I might do all of these just to, so it's 200 equals 2 to the power of x. Right, remember before we were estimating this, okay, you try and write that as a power of 2, but you can't. Right, okay, so what you need to do is you need to get the log of each side. Right, and the common log, girls, is the log to the base 10. Log to the base 10 of any number is a common log. It's called a common log, and there's actually a special button on the calculator, so you don't even have to write in the base 10. The button, it just says log on the calculator. Okay, so it just says log on the calculator. That's log to the base 10. Okay, so that's the common log is log to the base 10, and that's the log button on the calculator, so you don't have to type in the base. Right, okay, so what you do is you get the log of each side. So you get the log of 200 equals the log of 2 to the power of x. So you get to the log of each side, and it's to the base 10. And if you don't write in the base 10, write log means to the base 10. Okay, so if there's no base written, right, it means to the base 10. Right, okay, over here, log of 10 to 200. You know the way you can bring a power down in front? So you bring that power down in front, bring the x down in front, log of 2 to the base 10, and then you divide each side by log of 2 to the base 10 and log of 2 to the base 10. These cancel at this side, and you're just left with x equals, and this is calculator work. Okay, so in your calculator you put log of, just use the log key. Yeah, this is what I do, isn't it? I turned it upside down the other day and couldn't turn it back because I pressed on something on the yeah. Right, okay, so then that's just calculator work. Log of 200 on top, log of 2 on the bottom, and as I say, you can just use the log button. Right, okay, sorry, log of 200 on top, divided by log of 2. Hang on. I'm looking at 7.64338. Did you get that? And it says correct to 3 significant figures, so it's 7.6438 ... 3 three significant figures means I'm allowed to write three numbers. So I'm allowed to write the 7, I'm allowed to write the 6, and I have to stop at the 4, and I just have a quick look at the number after the 4 to make sure it's 4 or less, there's no change, so the answer is 7.64. So three significant figures means I'm allowed to write three numbers. Right, is that okay? Are we good with that? I might do these because I didn't do any of these yesterday. Okay, so 8 part 2 I will also do, I took that away. So it's 5 to the power of x equals 500. Okay, so when you're missing the power, girls, when the variable you're looking for is in the power, you use logs to solve it. You get the log of each side. The log 5 to the power of x equals log of 500. Now you can use log to any base. You can choose the base. Okay, the most common one is 10 because there's a button on the calculator and you don't have to type in the base. Okay, so I'm going to use log to the base 10, which is a button on the calculator, and it means you don't have to type in the base, but you could use log to any base. Right, okay, bring the power down in front. X times log of 5 equals log of 500. I'm just not writing in the base, if that's okay. And then divide by log 5, so you get log of 500 divided by log of 5, and that will give you x is equal to log of the log of God. I'm looking at 3.86135, 3.8613, and three significant figure knocks it off here. So just before the 1, so there's no change, so 3.86. Is that okay? Right, part 3.
Please, would Charlotte the schemaker go to Miss Garvey's office now, please? Charlotte the schemaker. The students from Victor 4 are taking part in the jump couture competition, and they are looking for used coffee pods from any coffee machine. There is a box in the library where you can leave your used coffee pods. Your help would be greatly appreciated. Thank you. Would any first year who signed up for the baking club please go to the old kitchen at 105, just first years today, please.
Right, okay, so you get the, when you're missing the variable you're looking for, if it's in the power, you get the log of each side. So it's the log of 3 to the power of x plus 1 equals the log of 25. Right, you can bring the power down in front, so it's x plus 1, I'll just put it into a bracket, times log of 3 equals log of 25. Any base at all, yeah. And the fact that I'm not writing a base means I'm using log to the base 10. Okay, right, but you can give it any base you want to, but the only thing is if you decide to give it a base 2, you have to use this button, right, and put in 2 every time. Do you know what I mean? Sorry, you can't see. Okay, so if you choose log to the base 2, right, okay, you'll have to use this button and put in 2 every time. Whereas if you just use the log button, that's log to the base 10, you don't have to put in the base. It says log, right, to the base 10 is understood. Is that right? You just don't have to type in the 10, right? Okay. Is it a big deal? Not really, no. Like if you're typing one number, right, I'd say you get over it. But anyway, right, so then divide across by log 3, so you get x plus 1 equals log of 25 over log of 3, I'm still magnified, sorry, over log of 3, into the calculator with that, so log 25, okay, and then it automatically opens a bracket for you on the log, girls. If you don't close the bracket, an error message will come up, so don't forget to close the bracket, okay? no, that's a line on the thing. It's just log 3. So x plus 1 equals 2.9299 dot dot dot. So that means x is equal to 2.9299 minus 1 when it comes over. So that means x is equal to 1.9299, and round that up to 3 significant figures. You're cutting it off there, so 1.93 is your answer. Is that okay? Bit squashed in there, sorry. Right, I might as well do the part 4. Sorry. 1.93. Right, okay. So part 4, right, is 5 to the power of 2x plus 3 equals 51. So as I say, when the variable you're looking for is in the power, you have to use logs to solve. So you get the log of each side, and log with no base written is log to the base 10. So I'm getting log to the base 10 of each side, but it's your choice, okay? Right, okay, and then you bring the power down in front, so it's 2x plus 3 multiplied by the log of 5 is equal to the log of 51. Then you can divide across by the log of 5. So 2x plus 3 equals the log of 51 divided by the log of 5 into the calculator with that. Oh, no. Oh, no. Yeah. Oh, for God's sake, what did I do wrong there? Log of 51. Oh, yeah. 2.44, so you get 2x plus 3 equals 2.4429 dot dot dot. Bring over the 3, so that becomes a minus 3, so that would be minus 3 onto that. And you get minus 0.55701, and then you divide by 2, so x is equal to that, divided by 2 equals minus 0.2785, and when you round that up, that's to 3 significant figures, it's minus 0.279, because I'm knocking it off here. And that's more than 5 or more increase. Okay? Is that right? Are we good with natural logs? Okay, so natural logs just means log to the base 10, and it's used to solve equations when the variable is in the power. If the variable is in the power, you have to use logs to solve. Okay? Before I continue with the homework, I want to talk about a natural log. Right? Okay? So a natural log, girls, is E is a number. There's this, you know the way pi is a number. Right, okay, E is a number. It's 2.71 something. .718, and again it's dot dot dot, it goes on forever. They came up with this number when they were investigating natural disasters such as earthquakes and whatever. When they were doing the maths on it, this number kept coming up. You know the way pi is 3.141 whatever, okay? So pi is 3.14 and it goes on forever, yeah? So this is just another constant that mathematicians kept discovering when they were doing all the maths on earthquakes and volcanoes and whatever, when they started doing equations for when they erupt and how they predict them and whatever. This was another constant that came up, right, okay? So, and they call it, right, log to the base e, right, of any number, right? E is this number, okay? Log to the base e, so it's just a number like log to the base 10, log to the base 5, log to the base whatever. It's just a number that kept cropping up over when they were doing maths on natural disasters. That's why they call it the natural log, right, okay? So they use it for decaying bacteria and stuff like that. They've noticed that this number kept coming up, okay? And they called it E, right, okay? And we use it in logs a lot, okay? Except they don't say it's log to the base E, girls. They call it ln x. So instead of saying log to the base E, they say ln x. But log to the base E is another way of saying ln. ln is another way. And again, there's a shortcut on the calculator for log to the base E. So all those sums there a minute ago, instead of doing log to the base 10, I could have done log to the base E. Right, and I get the exact same answer, right? And there's an ln key on the calculator. ln, right, okay, means on calculator, and it just means log to the base e, and it means, girls, you don't have to type in the base. Same way log meant log to the base 10, alongside it, it's right alongside the log button. Right, okay. It's right alongside the log button, and it's just a constant that crops up in maths. Yes. Yeah. Right. So it's just a constant that crops up in maths. Okay. And we'll see more of it further on in logs. Okay. But for the moment, that's what it is. All right. Okay. I left those out yesterday when I was going through the section. Okay, I'm not finished the section anyway. Right, back to the homework. So that was number 8. Number 9. Anyone need me to do number 9? Yeah. Right, okay. Express. So number 9 says y equals 2 to the power of x minus 1 plus 3. Express x in terms of y. So you want x in terms of y. So my last line is going to read x equals a load of stuff, right? So my last line is going to read x equals everything else. Is that right? Okay, so I have to get that x down, don't I? So I can have x equals everything else, right? Okay, so what I need to do is I need to bring that 3 over, so I just have the power by itself. So I'm bringing over the 3, so it's y minus 3 equals 2 to the power of x minus 1. Right, how do I get the power down? How do I solve it? Get the what? What do I do? Get that power down. When I'm missing the letter in the power, what do I use? What section am I on? Log, so I'm going to get the log of each side.
Okay, please, would Cameron Gardner, third year, come to reception now, please? Cameron Gardner.
Yeah, sorry. It's magnified. Right, okay, so I moved over the 3, right, minus 3. I got the log of each side, right, okay, because that's how I'm going to get that power down. Because rule number 3 says if there's a power, I can bring it in front and make it multiplied by. So that's y minus 3 equals x minus 1 times the log of 2. Agreed? So that means x minus 1 is equal to the log of y minus 3 divided by the log of 2. And then I want the last line to read x equals, so I'm going to leave the x there, and I'm going to bring over that minus 1, so it's log of y minus 3 all over log of 2, and then there's a plus 1. Okay, so my last line reads x equals everything else, all the y's and stuff on the other side. Is that okay? And then it says, hence find the value of x for which y equals 8. So that means x is equal to the log of 8 minus 3 all over the log of 2. Right, which is the log of 5 divided by the log of 2, and you just do that in the calculator. So log of 5 on top.
Did that say 8 minus 3?
Yeah, the part 2 of the question was y is 8. So everywhere I saw y, I put in an 8. So log of 2 close bracket equals, and they said correct to however many places decimals, 4 decimal places, so 2.3219 is what I got. Is that alright? Are we good with that? Yeah. Yeah. Right, number 10. Am I doing 10? Yeah, right, okay. Can I cover that? Have I cut anyone off? All okay. So number 10 is log of x to the base 10. They didn't have to write in that 10. 1 plus a, right? And log of y to the base 10 is equal to 1 minus a. Show that xy equals 100. So, any suggestions? I need to get logs in there. Any suggestions? Get the log of each side. Right, remember it's an equation, so I can do what I want to it as long as I do it to each side. So that's log of 10 of xy equals log to the base 10 of 100. Okay? Is that alright? Okay, so I'm trying to prove, right? Okay, I'm trying to prove this. This is what I'm trying to prove. So I've got the log of each side. Are we okay? Right, this is the product, isn't it? So the rule number 1, what can I split that up into? Log of x plus the log of y, can't I? Yeah? Remember that? Right, that's rule number 1. This, I can simplify this. What's log of 100 to the base 10? What's the answer? 2, isn't it? Because 10 squared is 100, isn't it? 10 to the power of 2 is 100. Are we all okay with that? Instead of log of 10 to the base, log of x to the base 10, what can I write? They must have told me that for a reason. I can write 1 plus a, can't I? Because look, they told me up there that that means it's 1 plus a. Yeah? Instead of log of y, what can I write? 1 minus a, right, equals 2. And then tidy this up, plus a minus a gone, 1 plus 1 is 2. So I get 2 equals 2, so that is a true statement. So I have proved what they asked me to prove. Is that okay? Yes. Yeah. Right, are we good? Did I give you 11?
Yeah.
Yeah. Am I doing 11? Yeah. Okay.
Miss, can you just go back to the-
Yeah. Sorry.
Yeah, okay, thanks.
Okay.
Yeah.
Right, number 11, so P equals log of the base A of 21 over 4. Q equals log to the base A of 7 over 3. And R equals log of the base A of 7 over 2. And it says, show that P plus Q equals 2R. Right, so this is what I'm trying to show or to prove, that P plus Q equals 2R. Right, okay, so I'm going to replace P with what's up here, log of A 21 over 4.
Miss, what does it say under the second sentence?
3 plus Q is log of A, which is 7 over 3, and I'm trying to prove that's 2 times log of A of 7 over 2. Agreed? This is what I'm trying to prove. P plus Q equals 2 times that. Okay? Right? This is a plus. That means they were originally what? They were originally multiplied, weren't they? So that I can turn that back into 1 log. So log of A, this was 21 over 4 multiplied by 7 over 3. Would you agree? Okay, which is multiply those, multiply fractions, you multiply the top and you multiply the bottom, or you could just multiply in your calculators, and when you multiply in your calculators you'll get, when you factorize, it'll be 49 over 4. Okay, is that right? I'm going to leave that for a minute. I'm going to work on this side, right? You know this 2 in the front, that was originally a power, wasn't it? Would you agree?
Yeah.
Is originally a power. So then I'm going to square the top and square the bottom. That's how you square a fraction. 49 over 4. And now the left side equals the right side, so basically it's true. Is that okay? That's number 11. And finally, we had number 12. I'm doing it. Right, number 12. Is it okay that I took 11 away? Do you want it back? Right, okay. Log of x to the base A is 4. And log of y to the base A is 5. Find the correct values of log of A of x squared y. Okay, right. I need to split it up into what? This is a product, isn't it? So that means I can split it up into a plus, can't I? X squared plus log of y. Agreed? This is a power, so what do I do with the power? Bring it down in front. So that's 2 times log of x plus log of y. Now I can replace these with the numbers. That is 4, so that's 2 times 4 plus 5, which will give me 13, and that's the answer to that bit. Okay? Part 2 is log of A of AXY. So there's 3 things multiplied here. So I can split them up and give them all pluses. So it's log of a to the base a plus log of x to the base a plus log of y to the base a. Right, 3 things multiplied, that means there can be 3 things plus. Log of a to the base a, what is that? 1. Log of x, what's log of x? 4. And what's log of y? 5. They told me up at the top of the sum. When I add those, you get 10. Is that right? And the last one, is log to the base a of root x over y. Okay, so I'm going to do 2 things in the one go, right? That's log of a of x to the power of a half, that's how you write the square root of x, minus the log of y, because it's a division, and rule number 2 says I can split up a fraction into the top, take away the log of the top, take away log at the bottom. Is that okay? That's a power. I can bring it down in front, so that's a half log of x minus log of y. So that's a half of x was 2 minus 5. So a half of 2 is 2, take away 5 is minus 3. That's my answer. Is that okay? Are we good? Right, I want to do logarithmic equations, okay? How am I going for time? I spent a lot of time. I'm going to run out of time now, aren't I? Okay, so will we do, we'll just do some more of these, page 490. I'm hoping there's no equations there. So let's do up to 22, except numbers 18 and 20, because I think I did those as examples yesterday. Right? Okay, so I didn't get on to log equations. Okay, so page 490, 13 to 22, except number 18 and 22, because I did those yesterday.